Hi, this is a presentation of dynamic routing protocols, and it's a part of my CCNA2 course. When we look at the dynamic routing protocols, they have been used since the late 1980s. We have different types and we have different versions of the different types, and the newest version will also, of course, support IP version 6. When we look at them, we can actually divide them into two overall types. We have the interior gateway protocols and the exterior gateway protocols. The ones that we are going to work with here in this course and this curriculum is the interior gateway protocols. These are used in a smaller setup than the exterior gateway protocols. So this is typically something that we use within a corporate network, for instance. When we look at the interior gateway protocols, there are two types. We have the distance vector protocols and the link state protocols. Examples of distance vector is RIP, and of link states it is OSPF. And both RIP and OSPF will also be found in a IP version 6 version of it. Examples of the exterior gateway protocols and the path vector protocols is called BGP, for instance. And I think that is covered in CCNP and not CCNA. Okay, the overall purpose of a dynamic routing protocol is to make sure that the router themselves exchange information about their different routes, so that they will discover remote routes that they are not directly connected to. They will update their routing protocols. They will choose the best path between the different networks, and it will also make them able to find a redundant path or a backup path if something goes wrong with the current path. So that is the overall purpose of having a dynamic routing protocols. To help the routing protocol do this, well, we have different types they need or different things they need to have set up or used for that purpose. For instance, we have the data structures. Many of the routing protocols use some kind of database to have this information about their neighborings, for instance, the neighboring routes and so on. We need some kind of setup for the messages, the routing protocol messages. Some of the routing protocols will send their entire routing protocol to their neighbors. Others will just send updates. That's different. And then we have the algorithm, how to calculate the best path. And that's also a huge difference on how they are doing it. We've seen earlier on that we have the static routes, which are good for smaller networks, or if we have a stub network with only one exit, or if we want to have a default route. That is because sometimes we will mix both dynamic routing protocols with static routing protocols. So for example here, if I'm in router 1, well, I only my entire access to the rest of the world, so to speak, is through router 2. So what I can do on router 1 is to set up a default network. So whatever is not my own local networks, I will send on to router 2. On router 2, we can see that in connection with router 1 only have 2 networks connected to it. So I can also make a static route to these 2 in router 2. Because there are, of course, some advantages of using static routing, which is that it's good for smaller networks. It's secure, more secure, because we don't read updates from other devices. We implement them ourselves. The route is always the same. There is no algorithm, no update, so we don't use the router's resources in any way. So that is why in the earlier example that could make sense to make a static route. Of course, if we have larger network, it's a lot of work setting up static routes, and we will never do that because the advantages of dynamic routing is that it is suitable for all topologies where we have multiple routers and we have multiple routes. It's independent of the size. We can scale it up as much as we want. And it will automatically adapt to changes. We don't have to reconfigure anything if we change something, because the routing protocol will then take care of that for us. It's a little bit more complex to implement. It is, of course, less secure, because now we say to the routers, you communicate with each other and update each other. So if there is a rogue router somewhere in my network, we can start sending wrong information all the way around. Of course, we can secure that with setting up some kind of authentication between the routes as well. Yeah, it will require more resources from the routers, of course, because it have to make calculation, it send out updates, so it uses both CPU, RAM, and the bandwidth of the links. Yeah. If we look at RIP version 2, this is the one that we have been looking at so far. It's a very, very simple and old routing protocol. We will configure it by using the command router RIP, and then it's important to understand, when we do that, we will tell our router which networks it should send RIP information out on, and we are doing that with the network command. And this is the networks that we are directly connected to. If in this example here we have router number 1, and I use the network command with the 2 directly connected network, which is 192.168.1.0 and 192.168.2.0. And then everything is set up. And then when my neighbor router also enables RIP, well, then they start exchanging information about these 2 networks. This is basically the 2 networks that I will send information out on, and it's the 2 information that I will tell, or the 2 networks that I will tell my neighbor about. To verify that I'm using RIP, well, then I use the command show IP protocol, and then it will tell me routing protocol here is RIP. And it will tell me whenever I will send an update. RIP will do that it will send out an update every 30 seconds. So it will actually generate a lot of traffic on my link. I can also use the show IP route and then begin gateway. Then I will also see, I don't know if I need the begin gateway. If I do just show IP route, it will show me with the R in front of it the routes learned according to the RIP protocol. Yeah. So if I want to, look at RIP and see how often it will send out information, well, then I can use the show out IP protocol. By general, it will send out every 30 seconds, and it will send out their entire routing table. To ensure that I use the newest version of RIP, I will use the version 2 command. This enables me to use subnetting. If I have any kind of networks that I've subnetted, I must use version 2. Some old iOSs will default back to version 1, so it's a good practice only to put always to put in version 2 to make sure that we are using version 2. Another thing that you should also be aware of when you're using RIP is that there is something called auto summary, and it's by default enabled. That means that RIP will always try to summarize the routes. Especially, you should be aware of this if you have done some subnetting, because if you have done subnetting, RIP will then try to ignore that and just summarize the routes that you have actually subnetted. So they will, you will not be able to see your subnets. To be able to have subnets, you have to use the command no auto summary. Then the RIP will look at your interfaces and use the subnet mask that you have applied on the subnets or on the interfaces. So if you're using RIP version 2, also disable auto summary if you don't want it. Of course, if you want RIP to summarize for you. It is a good idea if you have large network with continuous networks, then it's a good idea to keep auto summary enabled. But if you have subnetted and you want to make sure that will apply, then you use the no auto summary. It will not work on RIP version 1, but RIP version 1 is an old one that you should avoid anyway. Show IP protocols will also show you that you have disabled auto summary. Yeah. Another thing that could be interesting to do with RIP version 2, or RIP anyway, is to set up the passive interfaces. Because I know, for instance, here on router 1, I know that on my G00 interface, I will not ever have another router. So I do not need to send my entire routing table out on that interface every 30 seconds. But I cannot not put the network command in, because then I will not advertise my network to the rest of the routers anyway. So what I do is that I set my interface G00 to be a passive interface. Then I will tell my neighboring routers about the interface and the network, but I will not send network information or routing information out to that network. This will, of course, help in 3 ways. I will not have wasted any bandwidth on my interface where it's not needed. I don't waste any resources and security risks. Because security, if someone comes with a router on this local interface, and you can actually find out and start exchanging routing information. And I don't want that. The wasted resources is also that you don't have to send information that way out. Yeah, another thing I also can do with my dynamic routing protocols is that I can propagate a default route. So if I have a default route, if router number 1 is connected to the internet, well, then I can set up this information, the 4 times 0, to the rest of the networks as well. So if I use the command default information originate, then it will take my default static route and send that out together with my RIP updates, which of course also could be very helpful. Yeah, and that was it. That was the first part of this chapter. Thank you.